Hello, this is Professor White. Today we will talk about geometric sequences, and you should watch the arithmetic sequences in series before you watch this one. So it's just the two previous videos before this one that you can watch. This is kind of level is about algebra. Okay. What I'm going to talk about is just listing terms for geometric sequences, finding the formula for the sequence, general formula from a list, finding how many things you listed, finding n from from a list, and then actually figuring out, for example, if they give you 4 or 5 terms and then they're saying what is the 99th term, finding that. Okay, so let's get started. Okay. What is a geometric sequence? A geometric sequence is a list of numbers such as this: 2, 4, 8, 16. It can go forever, it can be infinite, or it can stop. 2, 4, 8. And all you have to do is, this one is finite. You have to figure out what the relationship is, and that relationship in a geometric sequence is r. You're multiplying the previous number by r to get the next number. So in this case, it's going to be 2, because 2 times 2 is 4. 4 times 2 is 8. So this is a geometric sequence with r of 2. So if you can also write like that, the first term is 2. The second term is 2 times 2. And the third term is 2 times 2 times 2, and so forth. Or you can write like that. You can just write 2, 4, 8, and so forth. So what that turns out to be, so you have that 2, and you're multiplying with 1 less each time. Okay, so in other words, an is your first term times that r that we're talking about, multiplied by that by 1 less exponent. Okay, so this one is a definition of a geometric sequence. For example, they may give you the formula. They may say, okay, well, if an equals 3n minus 1, can you list a1, a2, and a3? All you have to do is just plug it in for, let's say 1 minus 1, 3 to the 0th power is 1. This one is 2 minus 1. So that is 3 to the 1st power, that's 3. And this one is 3 minus 1, and that's 9. And you just plugged it into the formula and get it. Alright, or somebody may say, well, can you tell me what the formula is if I give you the list? Okay, let's say they give me 1/6, 1/3, 2/3, 4/3, and so forth. How does that work? This is a little bit trickier, so I might want to make a list here, n and an. So this is 1, the first term, second term, third term, and fourth term. That's all they gave me, so I just put this down. 1/6, 1/3, 2/3, 4/3. So there's something with the 3, okay? But then the first one is 1/6. But what am I doing here? And there's something with the 2 as well. Okay, so let's look at that. I can try a couple of things, but I can see the first term is 1/6. Remember how it works? So the first term is supposed to be a times r. What am I multiplying it by? 2. Okay, and then you are like 1 less, and minus 1. Okay, that's great. So once I recognize that it's a geometric series, I can write this with the help of the general formula, which happens to be Rn minus 1, where your A is your first term. Okay, sounds good. What else can I do? They may say, okay, well, can you get me the nth term or something? So they may say, okay, well, if my A1 is 3, or you call that A, and my R is 1/2, okay, I will tell you An is 3/1024. What term is that? What is that n? Well, you may say, well, I don't know. So write down the formula. What is the formula? An, A times Rn minus 1. So let's look at that. An is given 3/1024. And A is given, it's 3. And R is given, 1/2. Look at that. The 3's will go. So I have this situation. 1/1024 is simply 1/2n minus 1. Okay, this just became an algebra problem at this point. 2n minus 1 is simply going to match this, 1024. I can just go and break down 1024 and see, how many times I'm multiplying 2 by itself, or you can just use algebra. Remember the logarithms? Just for fun, take the ln of both sides. You have a calculator. 2n minus 1. Okay, what is that going to give me? That's going to go, oh, I remember. I'm complicating, probably you hate this, but ln of 2 equals ln of 1024. And n minus 1 is simply ln of 1024 over ln of 2. That means n is going to be 1 plus ln of 1024 over ln of 2. You can do that. Plug it in. You know what you're going to get? You're going to get 11. Another way you could have just tried a couple of different 2's and see when you get 2024. But this is very, very simple.